Hello class. So today is just a brief bonus so I can make more extensive the explanation about how to find the trigonometric functions of angles that are multiples of, as we know by now, 30 degrees, 45 degrees, or 60 degrees. Okay? Well, also 0 degrees and what happened? 0 degrees and 90 degrees. Now that we know how to calculate the trigonometric functions of these angles, we can find the trigonometric functions of any of their multiples. Okay, so how do we do that? We do it in this way. Let's suppose that I have not explained to you this topic. Okay, what we do is this. For example, in this case, they are asking me to find the trigonometric functions of all of these angles, 150, 240, 330, and 390, all of which are multiples of 30 degrees. Pause the video and make sure of that. All of these angles are multiples, not submultiples, okay? Not submultiples, multiples. For example, in the case of 150, it's 5 times 30 degrees, and so on. Okay, and we can get the trigonometric functions of these ones by making use of what we know about the trigonometric functions of 30 degrees. If you remember, the trigonometric functions of this angle were obtained by constructing this triangle. Can you remember? Where first we started with an equilateral triangle, like there was a side in here and another bit in here. We started with an equilateral triangle of sides 2, and then we divided it in 2 by a perpendicular in this way. Therefore, now this is 1, this side is 1, this hypotenuse is 2, this angle is 90 degrees. We could obtain this side, this cathetus, by the Pythagorean theorem, and this is an angle of 60 degrees. So remember, blue is 60 degrees and red is 30 degrees. Okay, so we know now how to calculate the trigonometric functions by making use of this triangle. We can calculate the trigonometric functions of 30 degrees and of 60 degrees, attending to the definitions of sine and cosine, etc. Okay, now how do I find the trigonometric functions of these ones? What you do is the following, guys. I replicated this triangle in here. I copied it and pasted it in here. It's the same triangle without the sides because I don't want this to be too cluttered. I want it to be looking clean. And what you do is you're gonna manipulate this triangle, this special triangle. Remember, they're called special triangles. I'm gonna manipulate it in space, like I'm gonna rotate it or reflect it, etc., in such a way that I can bring it to the Cartesian plane and help myself find the trigonometric functions of these angles. Okay, in the way in which you do this is the following. You will always pivot. Let me write that word because I don't want you to get confused. Okay, pivot, or which is kind of like anchoring. Anchoring. I'm gonna pivot, or I'm gonna anchor this red angle, which is the angle of 30 degrees. I'm gonna pivot it at the origin. What does that mean? That means that I'm gonna have it with this vertex, this little vertex right here, this one. I'm gonna have it at the origin, always, okay? That's what I mean by anchoring it. Lo voy a anclar aquí, o lo voy a pivotar. What does that mean? It means this. For example, like that. On this configuration, we say that this vertex, this vertex in here, this one, is anchored at the origin, or it's pivoted at the origin. Okay, that's what you do. And if you notice, one of the sides, or well, one of the catheti of this triangle is resting on an axis. In this case, this cathetus is resting on this y-axis. Okay, Now, let me tell you another configuration that would be possible. Let me bring it over here again. What about doing this? Look at this. Okay, I can bring it and I can anchor the red angle or the vertex of the red angle, which is 30 degrees. I'm going to anchor it at the origin, like so, and I'm going to have one of the catheti of this triangle to rest on one of the axes, in this case the x-axis. This configuration will also help me get one of these trigonometric functions. Okay, let's see how it works then. Let me first do 150. For 150, this angle is on this quadrant, right? So I'm gonna be needing to do something like this. Look, I'm gonna bring it. I manipulated it in here, as you could see. I'm rotating it and doing some sort of reflections. I'm gonna put it over here. My angle of 30 degrees is pivoting at the origin, and one of the sides of this triangle, this cathetus, is resting on one of the axes, which is the x-axis. Perfect. This triangle, guys, in this configuration will help me find the trigonometric functions of 150. How? Well, you must understand this. This triangle is the same as this one, so we know all of its we already know all of its angles, and now we know all of its sides. This side, according to this triangle, this side is the square root of 3. This one is 1, and the hypotenuse is 2. You see? And now, with this configuration, I can find the trigonometric functions of 150, because if you notice, this angle, guys, this angle, which is in a standard position, remember, this is the initial side. I'm starting to draw the angle from the initial side, and I stop it right here. So this is the terminal side of this blue angle, and tell me how much is this blue angle. Let's call it theta. How much is this? If I know that this red angle is 30, then therefore this blue angle is 150. You see? This is its initial side. This is its terminal side. And as we know, we can calculate the trigonometric functions of this one by choosing one of the points along its terminal side. Let me choose this one, this vertex of the triangle, you see? Let me choose this one, because actually I can find the coordinates of this point, okay? By looking at this diagram, by knowing that this triangle has catheti square root of 3 and 1 and hypotenuse 2. What are the coordinates of this point? Well, it's going to be minus the square root of 3 comma 1. Why? Because in the x, this is the square root of 3 as a side, but you know that when the x goes to the left, it must be negative. So don't make the mistake of writing a plus in here. That would be incorrect. This is the cathetus of this triangle. But as a coordinate, as the coordinate of this point, it must be written with a minus. And the y coordinate is positive because it's going upwards. So there you go. Okay, so now we have the point on the terminal side of this angle, and we also have the distance from this point to the origin, which is 2, according also to this triangle. And that's it. That's it, guys. We can now calculate the sine of 150, which by definition is the y coordinate over r, the distance. What is the y coordinate? Is 1. What is r? Distance is 2, and I'm done. The sine of 150 is 1/2. Cosine of 150 is by definition the x-coordinate over r. What is the x-coordinate of my point? Minus the square root of 3 over r, which is again 2. There you go. And tangent of 150 is y over x. So it's going to be 1 over this number. 1 over minus the square root of 3, and I'm done. You see, I have calculated the trigonometric functions of this angle, 150, which is a multiple of 30 degrees, by making use of this original special triangle and putting it somewhere in here so that it helps me do that. Okay, you have to get creative in the placing of the triangle. It's not too difficult. When you do it 2 or 3 or 4 times, you get the knack of it, and you will see that it's very easy. Okay, let's erase everything, and now let's go with the one of 240 degrees. Okay, so I bring back my triangle here, my special triangle. 240 degrees is living in the third quadrant, right? Because it's greater than 180 and less than 270. So it's over here. So I should place this triangle over here with the red angle pivoting at the origin and one of the sides of this triangle, one of the catheti resting on one of the axes. So which one is it going to be? It's gonna be this one. You see, you have to do you have to try some things. Okay, I did some things here. Okay, I reflected it in some ways, and then I rotated it in some ways, and this is the one that's gonna help me. Look at see why. I'm gonna put it here, right there, and I'm gonna start doing this. Okay, so look at this angle again in standard position. This angle, okay, how much is this angle? If we know that this red angle is 30 degrees, then with a simple geometry, how can I know what this angle is? How much this angle is? We know that the blue plus the red angle should be 270, right? And if I know that the red angle is 30 degrees, then by deduction, I can conclude that this is 240, because 240 plus this little bit, which is 30, make up for 270, which we know is this 3/4 of a full turn, 270 degrees. So that's how you do it. Okay, that's it. That's it, guys. That's the difficult part. Now the rest is just okay. I have my triangle resting in here. The small cathetus is 1, the hypotenuse is 2, and the other cathetus is the square root of 3. Then on the terminal side of this angle, which is this, of the angle of 240 degrees, I locate a point, I make a smart choice and go for this one, which is the vertex of this angle, so I can locate the coordinates of that point. What are the coordinates of that point? According to my configuration, that's going to be 1, well, minus 1, okay, because this is 1, you see, but negative because we're going to the left from the origin. And the y coordinate will be minus the square root of 3, because this is the square root of 3 and we're going downwards. So that's it. We have the coordinates of this point. It's this. We have its distance to the origin, which is 2. And I can calculate one more time the sine of 240, which is y over r, which would be equal to minus the square root of 3 over 2 cosine of 240. I'm just gonna do it now. There you go. These are the 3 trigonometric functions of my angle of 240 degrees. So you see how it works? It's not difficult. It's not difficult. With some practice, you can get it done very quickly. You can actually rotate the triangle in your mind and see which configuration should be the one that's going to help you out finding these trigonometric functions. Now let me skip this one. I think you already got it by now, and let me go with this one now, because you may get confused with angles larger than 360 degrees. So let me just give you that as a final example. Okay, let me bring my my triangle here. So 390 degrees. How much is that? Where is that angle? That angle, if you notice, that angle is actually a full turn. Okay, this is 360 already. At this point, I'm at 360, and then plus 30. Then this is the angle of 390. All of this angle that looks like a spiral, that's a perfectly good angle. There's nothing wrong with this. Okay, so it goes like this: is 90, 180, 270, 360, plus a little bit of 30 degrees, make up for this angle of 390. So basically, guys, if you notice, uh, we're going a full turn and then 30 degrees more. So this angle in here, this is 30 degrees, you see, and that's it. That's it. Then we can choose any point, sorry, over this terminal side of this angle, any point, and that's it's the same thing. We find the coordinates of this point, and then the distance from this point to the origin, and we are able to calculate the trigonometric functions of this angle. So basically, all I need to do is have my triangle look like this again, right there. You see, right there, because the angle that I'm trying to find the trigonometric functions of is this one, and such angle was like I repeat, it's all of this. It's one full turn plus 30. There you go. So it matches with this triangle. You see? Okay, and that's it. Find this the coordinates of this point. Remember, this cathetus is 1. This cathetus is the square root of 3. This hypotenuse is 2. And so the coordinates of this point will be the square root of 3, comma 1. And this is its distance to the origin is 2. And that's it. Sine of 390 degrees will be equal to y over r. So it's 1 over 2. Cosine of 390 is equal to x over r, which will be now this. And the tangent is this, which is this much. And that's how it works for angles greater than 360 degrees. Okay, basically we have the same trigonometric functions as the sine of 30 degrees. Okay, so that's how it works, guys. I hope you have understood. If some questions remain, you can ask me through a private message. And that's it. Now all you have to do is continue with the workbook 3.4 or either of the previous ones, and see you on Monday.